Hey everyone, Mr. Chapter back at you with an example of extreme value. So let's look at this function. It's a good looking function. Now even though there aren't arrows on the end of this, it's assumed that all these functions we use have arrows, even if Mr. Schachter is lazy and doesn't put arrows on them. Okay? So let's take a look at this one. Now first question is, what are the local maximums? Now remember, we're looking at the top of a mountain. So we have a local maximum right here. If you look left, there's nothing. Look right, there's nothing. That is the highest point as a local maximum, and it is at the location 2, 3. 2, 3 is the local maximum. All right? Local minimum. You scan the function, you look for places where it's the local minimum, the smallest point in some viewing rectangle, and that's going to be right down here. Now this is like you're standing at the bottom of a valley. Look left and it goes up, look right and it goes up. Therefore, that's a local minimum. And that is at the location 4, -5. 4, -5. Okay? Also, you need to find out what the domain would be. Now, since this function is infinite, meaning that it goes down forever and up forever, it also extends out left and right forever. And that means that the domain is going to be infinite. -infinity, infinity. And just to test, think about this. If I were to pick a point over here, would this point negative whatever, -1, be in my domain? Yeah, well, my function is going to keep extending out and out and out and out and out. So it's actually going to cover everything on the left side. And on the right side, it's going to keep going out and out and out, and it's going to cover everything into positive infinity. So it's an infinite domain. And likewise, if I scan up and down, so I'm looking at all the y values here, the y values will all be covered as well. So the range is also infinite. So we say the range is -infinity to infinity. Okay? Hope that was clear. Go try some problems.